Hello and welcome to another geometry lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 3, Lesson 6 on the angle-side-angle theorem. So in today's lesson we're going to introduce a new theorem like the side-side-side theorem and the side-angle theorem that we've seen in the last few lessons to prove two triangles are congruent. So let's get right into it. Here we go. The angle-side-angle. There is a third basic way that we can prove triangles are congruent. Similar to the other two, right, side-side-side and side-angle-side, it requires three corresponding parts of two triangles to be congruent. All right, and it's going to sound very similar to our side-angle-side theorem with a slight difference. Angle-side-angle theorem, or ASA. If two angles and the side between them, the included side, of one triangle are congruent to two angles and the side between them in another triangle, then the two triangles are congruent. All right, so in exercise number 1, let's go about proving the angle-side-angle theorem. Here we go. We will prove ASA using a reflection just as we did with SSS and SAS. In the two triangles below, it is known that angle DAC is congruent to angle BAC, AC is congruent to itself, and angle DCA is congruent to angle BCA. Letter A. If triangle ABC was reflected across side AC, explain why the image of B must lie on ray AD. All right, so in other words, right, if I take triangle ABC and I reflect it across AC, I just want to know why B must lie on ray AD. It doesn't need to lie on segment AD, but it does need to lie somewhere on ray AD. Pause the video now and see if you can give an explanation for that. All right, now remember, I don't know anything about the length of AB compared to the length of AD. Don't know anything about that whatsoever, but I do know that B must lie on ray AD because reflections preserve angles and angle DAC is congruent to angle BAC. Right, just to really kind of highlight what I'm getting at here, what I've done is I've taken angle BAC and I've tried to make it blue. Probably doesn't seem too obvious to you, but if I then reflect that across side AC, right, then what I see is that that ray AB, gets reflected up here so that it lies exactly on top of ray AD because again, angles are preserved under a reflection, under a rigid body motion. Now keep in mind again, B could be up here, B could be down here, B could be up here. We don't know because unlike the side-angle-side theorem, which we justified in our last lesson, here we don't know the length of AB compared to the length of AD. Okay? So let's take a look at letter B. If triangle ABC was reflected across side AC, explain why the image of B must also lie on ray CD. All right, well, this is pretty much the same explanation, right? Which is that reflections preserve angle measurements, okay? And this angle is congruent to that angle. In other words, angle BAC is congruent to angle DAC. So that if I reflect, right, that angle across side AC, then somewhere B's got to lie somewhere along here. So I'm gonna write down essentially the exact same explanation, all right, which is that reflections preserve angle measurements and angle BCA is congruent to angle DCA, right? If reflections didn't preserve angle measurements, then I mean B could be way up here or down here or up here. Or if these two angles weren't the same, right, then when we reflected it again, B would end up being wherever it was based on this angle size compared to this angle size. All right? Now, again, just like before, all that tells me, because I don't know how long CB is compared to CD, all that tells me is that B must be somewhere along this ray. Okay, it's got to be somewhere along that ray. Now, letter C, take a look at this. Using A and B, explain why B would get mapped to D when triangle ABC is reflected across segment AC. All right, see if you can go ahead and explain this. All right, well, B must be mapped onto ray AD and ray CD, and the only point that lies on both of these rays is point B. All right? And that's it, right? We know from part A that when we reflect this triangle over AC, B has to lie somewhere along AD, along the ray AD. We also know that because B lies on ray CB, when we reflect it across, its image must lie somewhere on ray CD, okay? But if it's got to lie on both ray AD and ray CD, then it must lie at point D because it's the only point that's common to both, right? And in fact, that idea, if I just flip this up or reflect it across, right, point B gets mapped to point D. And therefore, that shows us that if we've got the angle-side-angle scenario or situation between two triangles, that those two triangles must be congruent, because if we matched up the two congruent sides and then reflected one triangle across that congruent side pair, then it must map onto the other triangle. All right, cool. Now we have angle, side angle. Now that we've shown why the angle side angle condition leads to triangles being congruent, we can use this theorem in proofs. So let's take a look at a proof that is, not surprisingly, going to involve the angle side angle theorem. Let's do it. Do the following proof given the t-table provided. Segment GF and EH intersect at I. GI is congruent to FI, and angle G is congruent to angle F. Prove triangle HGI is congruent to triangle EFI. All right, so let's talk about our givens and mark them up on the diagram. Now the first one, GF and EH intersect at I, there's really no way that we can really mark that up, and you may even wonder, why did they give us that? Again, the reason that this given is given, right, is because for all we know, GI and F don't really have to be collinear. HI and E don't have to be collinear. But as soon as they tell us this, then we know, oh, GF is a segment and EH is a straight line segment, and they happen to intersect at I. Again, not much I can do to mark that up, not for right now. We'll get there in a bit. Now, GI is congruent to FI. That's simple enough, right? I'm just going to make a dash mark right there, right? Angle G is congruent to angle F, also very easy. We'll just mark that there and there. Okay, now let's talk about how we can use angle side angle here, because we definitely have an angle congruent to an angle and a side congruent to a side. But where does that other angle pair come? And keep in mind, to use angle side angle, right, the side pair that we know that's congruent to each other, that has to be located in between the pairs of congruent angles. Well, what we should always be watchful for in geometry proof are vertical angles, because they're kind of like a freebie. And that's really what that first given gets us. The fact that these two segments intersect at I tells us that we can now conclude that that is a vertical angle pair, right? And now we've got our angle-side angle condition. So let's write up the proof. It's pretty simple. Let's start. Let me try to get rid of that. Let's start with our givens. GF and EH intersect at I. Simple enough. Given. Right? Let's get our next given out. GI is congruent to FI and given. And our final given. Angle G is congruent to angle F, given. Now again, I've mentioned this before. I'm going to take some time to mention it again. Given that all three of those things have the same reason, which is given, you could lump all of these in the same line if you wanted to, and then write down given as your reason. All right. Now, what else did we know? Well, we knew that angle GIH, which is this one right up in here, is congruent to angle FIE, which is this one right here. What is my reason for that? Well, my reason for that is vertical angles are congruent. And that was the last little piece I needed to finally conclude that triangle HGI is congruent to triangle EFI by the angle-side-angle congruence theorem. All right. Pause the video now and write down any of the statements or reasons that you may have missed due to how fast I was going. All right, great. Simple proof, right? We want them all to be that easy. Make sure I'm not missing anything. Excellent. All right, filling in a proof. On occasion, you might be asked to fill in either missing statements or missing reasons from an otherwise completed proof. All right, and mostly this isn't about geometry so much. This is about what you might see on a test or a homework assignment or even a state exam. It's not unusual for you to see sort of a semi-completed proof. Notice here I'm missing some reasons, I'm missing some statements. Oftentimes you have to fill in more of the reasons than you do the statements, because doing it that way is a little bit backwards. But anyway, let's look at the setup. Exercise number 2. Given segment MQP, segment NQ bisects angle MNP, and segment NQ is perpendicular to segment MP, prove triangle MNQ is congruent to triangle PNQ. All right. Well, before we start filling anything in, let's do a rough sketch of how this proof should go. As always, the statement segment MQP is telling us simply that these 3 points are collinear. And again, that could be very important. Now, segment NQ bisects angle MNP. That tells us that this angle and this angle are congruent to each other, right? Those two angles at the top of the triangle are congruent. Excellent. Now, we also know that segment NQ is perpendicular to segment MP, all right? And that tells us that this angle is congruent to that angle. Now, those are all the givens we have, and remember, we're kind of keeping in mind that this could be an angle-side-angle proof. Well, we've got an angle congruent to an angle. These two angles can be congruent because all right angles are congruent, and we need the side that is included, that's in between them. Well, that happens to be the shared side, NQ, all right? That whole NQ is congruent to NQ by the reflexive property, all right? So we now need to fill in the rest of this proof. What I'd like you to do is pause the video now and see if you can fill in both the missing reasons and the missing statements. All right, well, the first one should be easy. NQ bisects angle MNP. Simple enough, right? That's given. Now, angle MNQ is congruent to angle PNQ. Those are, this angle and this angle. Why is that? Well, the reason should be something along this line. Angle bisectors form two congruent angles. And if you said, bisectors cut an angle in half, or angle bisectors cut an angle in half, or something like that, that's fine, all right? Now, right, we have this angle congruent to that angle. we want this side congruent to itself, and that's going to be statement number 3, right? NQ is congruent to NQ, the reflexive property. Anytime we have a reflexive property, we know we're basically just saying something is congruent or equal to itself. All right, now NQ is perpendicular to MP. Well, that's just that given, right? So that should be simple. Angle MQN and angle PQN are right angles. Well, that's something like perpendicular lines form right angles, or perpendicular segments form right angles, something like that. Now, reason number 6, all right angles are congruent. That reason should only be given if you've suddenly set 2 right angles congruent to one another. So, angle MQN is congruent to angle PQN, all right angles are congruent. And finally, triangle MNQ is congruent to triangle PNQ. That is by the angle-side-angle congruence theorem. And again, if you just said ASA here, you might want to check with your teacher, but generally that's accepted in these situations. All right, pause the video now and write down any of the reasons or statements that you need to, and then we'll move on to the next exercise. All right, let's do it. I kind of like the fill in the proof problems. You know, they're a little bit weird, but you know, you'll see them on and off. All right, back to CPCTC reasoning. Corresponding parts of congruent triangles are congruent. Anytime you're asked to prove 2 segments are congruent or 2 angles are congruent, you are likely first going to need to prove that 2 triangles are congruent and then use CPCTC reasoning. So, you know, in something like exercise number 3, where the final statement is prove that segment AB is congruent to segment CD, you know, your first real thought should be, oh, I'm probably going to have to prove 2 triangles are congruent that have AB and CD as corresponding sides, and then I'll make that conclusion based on CPCTC. You should never conclude and use CPCTC as a reason before you know that 2 triangles, or before you've proven that 2 triangles are congruent. If so, then your logic is completely reversed, and boy, do you suffer a big point penalty in terms of what kind of grade you'd get on a proof. Anyway, let's take a look at exercise 3. Do the following proof using CPCTC reasoning. Given, angle DAC is congruent to angle BAC, angle DCA is congruent to angle BAC, prove that segment AB is congruent to segment CD. Okay, so let's mark up the givens, but then I'm going to turn you loose and see if you can finish the proof. So first, DAC is congruent to BCA. That's going to be this angle is congruent to this angle. All right, angle DAC is congruent to angle BCA. All right, our second given is angle DCA is congruent to angle BAC. So DCA, which is right here, is congruent to BAC right there. Okay, so I have an angle congruent to an angle congruent to an angle, and now, of course, I've got a side that is shared between the 2 triangles, specifically AC, and that rounds out the conditions we need for an angle-side-angle in order to prove the triangle, right, ADC is congruent to triangle CBA by angle-side-angle, and then we could conclude that AB is congruent to CD by CPCTC. Pause the video now and see if you can write this proof on your own. All right, let's do it. Well, no great surprise. Let's get our givens down, right? Our 2 angle pair givens, simple enough. That's what I marked up right at the beginning. Now the other piece that we need for angle-side-angle is that shared side. So that's where we're going to say CA is congruent to CA or AC is congruent to AC. Either way, it doesn't matter, right? That's our reflexive property, or the duh property. I mean, again, we can't use the duh property, but we can use the reflexive property, right? Now, we have to be careful here. I know that that means that this triangle is congruent to that triangle, but one thing that people are going to be watching when they grade your paper is to make sure that you get the corresponding vertices in the same place. So, There's many different ways of doing it. I'm going to say triangle DAC. So DAC, of course D corresponds with B, A corresponds with C, right? So we've got D corresponding with B, A corresponding with C, and C corresponding with A. And that is the angle-side-angle congruence theorem. Now again, let me just revisit this whole letter thing, right? It's important that you don't just say, well, okay, DAC and ABC, right? The letters here have to match with their corresponding vertices here. So finally, AB is congruent to CD by CPCTC. Where's my reason? There it is, by CPCTC. I missed. It's hard. They're invisible. Trust me, they're invisible to me, they're invisible to you. Nobody can see them until I tap on them. All right, pause the video now, write down anything you need to. All right, let's do it. Last problem. Here we go. Exercise number 4. Given segment QUR, U is the midpoint of ST, and angle QTU is congruent to angle RSU, prove that angle TQU is congruent to angle SRU. All right, great. So I'd like you to pause the video. I'd like you to mark up all the givens and see if you can work your way through this proof. All right, as always, this piece, given segment QUR is telling us that these 3 points are collinear. All right, so not much I can do to mark that up. U is the midpoint of ST. That I can do some marking on, right? So I can say we've got SU congruent to TU, right? Because of the midpoint piece. And angle QTU, which is right here, is congruent to angle RSU, which is right here, or I'm trying to make it right there. There we go. All right. Now, we've got to get that second angle pair congruent in order to use angle-side-angle. And we have it with those two vertical angles. And again, the reason that we can say that those are vertical angles is specifically because we know QUR, those 3 points are collinear. If we didn't know that, then there would be no way of knowing that these weren't like somehow bent in some way. All right? So I can now say that angle is congruent to that angle, right? That's going to allow me to conclude that triangle QTU is congruent to triangle RSU. Once I know that, I can then conclude, and let me mark this in a different color just so that you realize it's not a given, it's what I'm trying to conclude, that TQU, I want to conclude that that is congruent to that, right? That's what I'm trying to prove in red. Let me circle it so that we really got that. You never want to confuse what you're trying to prove with what you know, and that's easy to do, especially if you mark it up on your diagram. All right, let's go through the proof. Here we go. Oh no, not that. Let's try it again. All right, QUR, easy enough. Given, right? U is the midpoint of ST, given. Angle QTU is congruent to angle RSU, given. Okay, we got our 3 givens out of the way. That's called a given dump, right? Given. Sometimes, by the way, I won't put all the givens up front. I might have them somewhere later in the proof if they make more sense later in the proof, sort of logically. But we'll get to that case, maybe even in the next lesson. All right, so now, SU is congruent to TU. That's, this little piece. And why did I conclude that? I concluded it because I know that midpoints form congruent segments. Or you could say because a midpoint divides a segment into 2 congruent segments, or something to that effect, right? Now I got to get those vertical angles in there. Angle QUT is congruent to angle RUS, and that's because vertical angles are congruent. And finally, I can conclude that triangle QUT is congruent to triangle RUS. Again, very important that you get these in the right order. Doesn't matter what order you put the first set of vertices in, but then the second set has to correspond. And that's the angle-side-angle congruence theorem. And once I know that, I can then conclude that angle TQU is congruent to angle SRU by CPCTC. All right, that's it. Pause the video now and write down anything you need to. All right, let's wrap this up. So in today's lesson, we saw the third fundamental way of proving that two triangles are congruent, angle-side-angle. Now we are going to have two more of them after this, but those last two we're going to actually prove not by using rigid motions, but by actually using one of the three fundamental ones that we already know. All right? But we're going to get to those in future lessons. What we saw today is that if we've got two triangles that share, right, that have two pairs of congruent angles, and the side that's in between those two angles also is congruent between the two triangles, then they are congruent to each other. We got more practice in this lesson, not only just using the angle-side-angle theorem, but also using the concept of CPCTC, i.e., if we want to prove that two segments are congruent or two angles are congruent, then what we first often have to do is prove that two triangles are congruent that have that pair of sides or pair of angles in them. All right, well, we'll work on CPCTC and a lot more in future lessons. For now, I just want to thank you for joining me for another geometry lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.